Hello, this is Karen Rhodes. I'm the consulting architect for HP Networking in the Central United States, and today I'm going to be discussing configuring IRF on 3 different HP advanced switches. IRF is Intelligent Resilient Framework. It allows you to take multiple physical switches, bond them together so that they appear as one switch with one master configuration, and these switches can be up to 80 kilometers apart, and if one of them should fail, your failover is under 50 milliseconds. Since this is a layer 2, layer 3 bond, you don't have to wait for things like OSPF adjacencies to time out should one of these switches fail. It's a very handy technology in data centers, but we're also seeing this quite a bit in the campus as well, so let's get right into the lab. In this lab, we're going to be using 3 HP 5830 switches. They're all running the 5.20.99 release 1109 P06 code, and we have 3 10 gig direct attached cables. IRF does work on the advanced series line, whether it be 1U switches or chassis based switches. The only change in this lab, if you were using a chassis based switch, is that you would need to use the command chassis convert mode IRF in addition to the commands that we're going to do in this lab. So I've set this lab up in 3 different sections. The first section is pretty straightforward. We're giving these different switches numbers. So switch number 1 is already number 1. That's just the number that all of the switches are going to have by default. Switch number 2 we have to renumber to number 2. Switch number 3 we have to renumber to number 3. Pretty simple. So here's the second part of the lab, and it looks a bit daunting until you realize that it's simply a repeat of the configuration that you do on switch 1, switch 2, and switch 3. And it's a breakdown of really 3 main tasks that we're performing on each switch. The first thing that we're doing is we're taking the 2 10 gig ports that we want to use for cabling these switches together, and we are shutting them down. The second step is we are creating IRF virtual interfaces, these IRF ports. The first IRF port gets assigned to port 51. The second IRF port we're assigning to port 52. Then we're exiting it out of that configuration mode. And then finally we reactivate or undo shut ports 51 and 52, exit out of there, and then activate the IRF port configuration, save the config, and that's all we're doing. So if you look at the switch 1, switch 2, and switch 3 configs, you'll see that I've highlighted in red the only differences between these, and it's simply the numbers 1, 2, and 3. Okay, so let's get right into the configuration here. What you'll see is the first step is on switch 1, since it doesn't need to be renumbered, we are doing the shutdown of ports 51 and 52. Tab is your friend here, so make sure to use that wherever you possibly can. After we've shut those ports down, then we go ahead and create our IRF port 1/1. So we're on chassis 1. We're using port 1. We assign it to 10 gig port 1051, which is the first 10 gig port we have available. Then we create IRF port 1/2. That's once again chassis number 1, port number 2, and we assign it to 10 gig interface 1/0/52, which is our second 10 gig port on this switch. After we do that, we unshut the 51 and 52 ports. We activate the IRF port configuration on this particular switch, save the config. It'll go ahead and ask you, do you want to really save it? This is going to override it. It'll validate the file. And I have gone ahead and left this timer in here because some people don't know exactly how long it should take for this file to actually write, and I want to give you guys a real world example. Later on I will be taking out reboots and things like that. So after switch 1, you see that we'll move over to switch number 2. And since switch number 2 needs to be renumbered, let's go through that process. So we have IRF member 1, which is the native number that it always has. We choose renumber 2. It will tell us that this is going to overwrite a config. If we had a configuration on switch 2 at this point, you need to back it up before you renumber, before you try to bond this into an IRF IRF grouping, because if you have a config that you want, and this is switch 2 or switch 3 in an IRF group, that config will be lost. Only switch 1's config is going to be saved, and that's going to be pushed down to switch 2 and 3. So at this point, it will go ahead and ask us to reboot. So after we've saved it, we quit out, and then you actually have to reboot. The reason you have to reboot here is that it's actually writing it to the system board, that the new name for switch number 2 is 2 instead of switch 1. So let's do the same thing on switch number 3 here. So IRF member 1 is the default number. We renumber it to 3 because this is switch 3. It asks, are we absolutely sure? Do we want to save changes? Yes, of course we do. It gives us the lovely warning here. And then after this, we'll just go ahead and do a save, and then we will go ahead and reboot after this. Once again, this is a destructive process on switch number 2 and switch number 3. So make sure that you have all of your configurations copied off before you do this process. So once again, the steps that we went through is switch number 1 did not get renumbered, switch number 2 got renumbered, and switch number 3 was renumbered. Since switch 1 did not require renumbering, the configurations have all been completed for switch 1 now. The system view, shutting down the ports, assigning the IRF ports, and then restarting or unshutting the ports 51 and 52, and then activating the IRF configuration. So now we're going to do the same exact thing on switch number 2 and switch number 3. Okay, so we're going to do the same exact configuration that we did on switch 1 on switch 2 at this point, and you'll notice that the port number is 2/0/51. The reason that it's 2/0/51 rather than 1/0/51 is that we did renumber that chassis to 2, so the heading number is going to be whatever that chassis number is. So we're doing the same process. We go to interface 51 and 52, we shut those ports, then we create the IRF port group. At this point we're on chassis 2, port number 1, so it's IRF-port 2/1. That's for interface 10 gig 51. Then we're going to go ahead and create the IRF port 2/2, so it's chassis 2, the second IRF port, and that's going to be bonded to port 2/0/52 on this particular switch. Then we undo the shut on the port 51 and 52. After we've done that, then we go into the IRF port configuration, make it active, save our config. It once again will ask us to, do you want to really overwrite this? Of course, yes you do. It'll validate the file, and then we're going to hop over to switch number 3, and we'll do the exact same configuration here. Anytime that you're confused on which switch you're at, it really does help if you, before you start this process, set your host name to the switch number that you think you want this to be. So switch number 1 I set to switch 1, switch 2, switch 2, switch 3 is switch 3. You'll see at the end of this configuration that when all these bond together, we'll only have the switch 1 host name though. So we're now on switch 3. Switch 3, we're doing the same exact thing, guys. Port 51 and 52, you shut those down. After you've done that, then we create IRF port 3/1 because we're on chassis 3. Then we assign it to port 51. Then we're going to go in and go to port 3/2. So third chassis, second IRF port. We're going to assign that to third chassis, second IRF port, which is 3052. Exit out of there, then go into ports 51 and 52, undo shut on those again, and then we'll go to the IRF port configuration and make that active. Once again, up arrow, tab, they're all your friends. So use them, especially with these longer commands. They definitely make things go a lot faster for you. It asks if we want to make it active. Yes, we do. Save. This will override it. Yes, you do want to save it. At this point, if you did not hit save, if you did not actually type it in and you rebooted the switch, it would not keep this information. So that's why you have to hit save. After we've done these, now is whenever you want to connect your cables. So you'll see lots of cable connections going on here and lots of port index coming up, things like that. What is going to happen when you connect all of the cables is that switch number 2 and switch number 3, since they're new to this IRF group, they will reboot. And what they're doing at this reboot is that they are actually taking the config from switch number 1, bringing it into switch 2, bringing it into switch 3, making that their own configuration, knowing that the switch number 1 is the master for this particular IRF stack. As they reboot, any previous configurations are erased. Also, it's making sure that the OS on all of the switches is identical. So you're going to either upgrade or downgrade to whatever the OS version is that's on switch number 1. Okay? So it is not taking the newest version. If you had, for example, an older version of OS that you guys have tested in your environment, you know it works, and you put that on switch 1, that is the OS that is going to be assigned to switch number 2 and switch number 3. So you'll see that before the switches reboot, before they come up online, you'll see that you have a master and that your ports are, showing your local ports, but really nothing else is going on. Your links are down. So right now I'm just being impatient with the reboot process. But this is pretty important part for you guys to see, because I do want you to actually see all of the different commands or messages that come across on console as your switches are coming up, as your links are becoming active, and as IRF is starting to bond these switches together. So we see that the second switch here is now starting to come up. So member is 2, member ID. So you see a little bit of information here coming up, a board state change. But really, we're seeing a master. We see 2 slaves now. We didn't have that before. But we only see 1 IRF port. So we know that it's still in that beginning stage of everything coming up. Our links are up. And you see that switch 1 has a neighbor of switch 2. Switch 2 is neighbor of switch 3. Switch 3 has a neighbor of switch 1. And a little bit after this, I'll actually show you a diagram of how everything is connected. Now we see that switch number 2 is coming up. Sorry, switch number 3, I apologize, is coming up. You see gig 2/0/52/51, and you saw 3/0/51 and 52. Now it shows you that the backup process is finished. Now whenever you do a display IRF, you see all 3 devices, but whenever you do the display IRF configuration, now you truly see the IRF configuration. You see that you have port 1051, 2051, and 3051. So here's the actual config, guys. If you wanted to see what IRF truly looks like after it's configured, you can see that gig 101 is in this configuration that exists on chassis 1. And as you scroll through, you'll then see the end of chassis 1, the beginning of chassis 2. So gig 201 is the beginning of that second 1U switch in this case. Then as you scroll further, you're going to see the third switch, So here we go, gig 301. So every one of your chassis, whether it's a chassis with lots of cards in it or whether it's just a one-use switch, you're going to see the number at the very beginning. And you may have noticed that all of our 1 gig connections were together. Well, here are all of our 10 gig connections. So we only had 2 per switch, 1051, 1052, 2 zeros and 3 zeros. So those are your 3 chassis. And here's your IRF port group. So this is the bonding that you did where you created chassis 1, port 1 going to port 51, IRF 1/2 going to 52, 2/1 going to 51, 2/2 going to port 52, and the same for chassis number 3. So that's IRF in a nutshell. Hope you guys have found this useful and informative, and if you follow these steps, it will work. Make sure that you do not connect your cables until after your configuration is done, though. That is the #1 mistake that most people make. Okay, so as we saw, as soon as you connect the cables up in this environment, switch number 2 and switch number 3 are going to reboot. They're going to take the configuration and the OS from switch number 1, but they do have to go through a reboot process as soon as you connect those cables. That's what initiates that reboot. The way you want to connect your cables is kind of in a diagonal manner. So switch 1, port 1 to switch 2, port 2, switch 2, port 1 to switch 3, port 2, and then switch 3, port 1 to switch 1, port 3, which I've indicated here with kind of a red line on the diagram. It really makes it a lot easier to add and remove switches if you do this diagonal type pattern with IRF. Otherwise, it makes it kind of a pain. So whenever you add switches, remember the switch that you're adding will have to reboot. None of the other switches in the stack will reboot though. And if you need to remove a switch from the stack, you can remove it. It does not reboot the switch, does not reboot the stack. And the one oddity is that you have gone through a renumbering process on that particular chassis. So if you renumbered it to, for example, number 3, you would end up seeing the port show up as 3/0/1 for your port 1 as an example. If you wanted it to say 1/0/1 rather than 3/0/1 after it was removed from the IRF grouping, you would need to type in IRF member 3 renumber 1. The switch would then reboot in order to take the new chassis number of 1, and then you would see all of your configuration as 1/0/1. I hope that this has been informative and that you guys have learned a lot from this video on IRF. If you follow these steps, it should work just fine for you. And remember, if you have a chassis with multiple cards, you do have to add in the additional command from the very first screen. Thank you very much for listening.